2017. I hope you can hear me and see the welcome slide. You can use the chat box to either ask a question or mention anything during the presentation. And Claire will answer hopefully as we go along. Claire's sort of with me in the office today. But welcome anyway. 28th of February, so it's the last day, meteorologically speaking, of winter, and seems a relevant time to be talking to you about this year's field season. So I'm hoping that the content of the presentation, which is going to be roughly 40 minutes long, will give you some inspiration and ideas about how maybe you can improve your current field workflow, and maybe how we can help you along the way. So just a quick run through of what I'm going to talk about. Really diving into some of the more common questions that we get asked from existing customers and people we meet. And we worked out over the last 3 years since MGIS was founded that we've probably spoken to a good 500 people with similar sorts of problems. And when I say similar sorts of problems, some people might have actually not took the step to using a digitally based workflow as opposed to pen and paper. Others might have had experience with using devices, software for field data capture, maybe good and bad experiences. And the industry itself has gone through somewhat of a transformation and change over the past few years, and we've seen a lot of development in existing applications, replacement of old applications, and also development of our own application and platform for data capture in the last 12 months or so. And this is really what I wanted to touch on today, is give you an idea of what's available on the market. And also some of the solutions that we've been developing on the basis of both customer feedback and maybe a limitation of some of the more commonly known applications that exist in the field. So hopefully that'll give you a flavour of what we're going to go through today. What we also specialise in is being able to enhance the accuracy of an existing field solution using GPS, or what's more commonly known as GNSS nowadays. And I'm going to give you some ideas to how you can improve the accuracy of field data capture. But alongside that, we've also got some existing use cases. So these are people working with environmental services applications who've been deploying technology that we've recommended to them, whether it's a piece of hardware, a piece of software, or a complete solution. So we've got some use cases that we'll talk about there. And actually then some options for both purchase and rental. If, for instance, you might only have a seasonal need for field equipment, or you might just want to improve the accuracy on a periodic basis and not invest fully in high accuracy GPS equipment, we've got options for that as well. Okay. So just really a quick bit of information about ourselves, and that's where we see ourselves as specialists in enabling digital spatial data in the field, and alongside this providing really a seamless approach to your data workflow, so as few steps as possible to get data to and from the field and into back office applications or into a format that your client needs. And looking at this from a cost-effective point of view, there's lots of solutions available on the market, enterprise-level solutions, which might, to the smaller consultant be cost prohibitive. And then in terms of enhancing accuracy of field data capture, there are lots of technology on the market, but all have sort of a variety of price points. But actually, what is the best solution for your accuracy requirements in the field? But ultimately, we try to aim for a return on any investment you make in a solution, a return on investment across a single project, and increasingly that's what we're finding with the type of solutions that we offer people. Okay, so these are some of the questions that we most commonly get asked, and they come from a number of different sources. It could be enterprise customers, they could be existing customers of ours, or they could be people just reaching out to us for the first time. But more and more, we see, even on an enterprise level, people needing to improve the accuracy of captured data, and that might be because there's a lot of legacy data that's in a client system, an old database that really hasn't been delivered, or the data hasn't been captured positionally to a required degree of accuracy, so that when it's mapped or when people try to relocate that data, it's just not fit for purpose. So how can we cost effectively and efficiently improve the accuracy of that field data? And that really answers the second question as well, because a lot of the time you're getting existing records, existing databases that you're having to use as a baseline for improving. One of the things we always get asked is, how can we more effectively share data, both with colleagues or other subcontractors that we're working with on site, and alongside that, clients. So it's one of the questions that we've tried to answer with our own sort of platform development. And it may serve a requirement that you have. It might be over-engineered for some other people, but it's there as part of the solution. More commonly, the question we get asked is, how do we get that data that I'm capturing into the right format for use by the client, the right format for reporting, and the right format for maybe exporting into another third-party system, which could be a CAD system or a back-office GIS system or another database package. Hopefully we'll answer some of those questions. But underlying all this is a question that we very often ask ourselves, which is, with all the technology that's available now, and it is a real minefield to a lot of people, there really has to be a more efficient, simpler and cheaper workflow for measuring, reporting and sharing data. So which workflow is best for me? And that's a question that you might ask yourselves. So the first question we would ask you is, well, in your day-to-day work, do you return to the office at the end of every day, or certainly several times during the week? And if that's the case, then it may well be that you would benefit most from what we call a disconnected workflow. And you might just have a single requirement to go out and capture data into a specific workflow. So let's assume you're an arborist and you're having to undertake BS 5837 surveys for tree risk. That data then goes into a CAD package that you already license, or a GIS tool. So it's a specific task that you have to undertake. And this then becomes a very repetitive requirement. So it's a specific type of workflow, and the fact that you are coming back to the office each day means that you don't really need any of the sort of more modern cloud-based infrastructure that exists. You don't need to share that data in real time with other colleagues. So in this case, and this is the way a lot of people have worked historically, they generally purchase mobile GIS with an upfront license cost. And then on top of that, you might have a piece of hardware, and all your data and maps, ordnance survey data, aerial photography, and your data layers, they all exist on the field device at any one moment in time. So you're not constantly uploading and downloading data. Alongside that, because you return into the office, you have a direct PC interface. So you're able to do that data upload and download. And typically, we've been involved in supplying those sorts of systems over a number of years. A product called Digitaire, which many of you may be familiar with. We also serve a lot of Esri customers who, from a legacy point of view, would have been using a product called ArcPad or ArcGIS for mobile. And then more recently, because of some of the limitations in Digiterra, but there's still quite a big need for a disconnected workflow, our Geography M solution, which I'll be introducing you to later in the presentation, still has a disconnected workflow capability alongside it. And similarly with GIS as a desktop platform, which many people use, people don't have the resource or the capability or the financial clout to invest in something like an Esri platform. But QGIS as an open source GIS has sort of grown immensely over the last decade or so, and increasingly we are integrating whatever tool a mobile GIS product with within a QGIS environment and building an end-to-end solution for people. But then on the flip side, you have many organizations, larger consultancies, enterprise organizations such as utility companies or big environmental services companies who need to send and retrieve and share information whilst on site. It might be for decision making, it might be because you've got a large field team and you need them to see what everybody's doing. So this has been part of the drive towards more of a connected infrastructure, really on the back of internet capability, cellular coverage, and also cloud capability. But we've kept a close eye on the development of those technologies over the years, both from a mobile GIS point of view and a connectivity point of view, and it certainly has influenced the way we've started developing our products. We also then need to look at the requirement for multiple data flows, because we're working with lots of back office requirements, lots of different GIS products, different database products and CAD tools. So we need to make sure our recommendations actually reflect the customer need. But more and more these occasionally connected solutions, as we call them. So you can't always rely on cellular coverage or internet coverage wherever you are in the world. So it tends to be an occasionally connected approach that we recommend, where you mightn't have all your maps and your data at all times, but you can cache the data locally to your device for that location that you're going to be going out to, and then you're not reliant on an internet connection at all times, but you still can get data to and from the office or to and from the cloud very quickly as soon as you've got a connection. But typically these types of workflows and the software solutions that go with them are subscription based. So you're paying a monthly fee as opposed to an upfront license cost, which again has some advantages. You're not having to front a larger cost up front. However, then there will be an ongoing license cost. But then with that, you've got all your software maintenance and your support costs ongoing. Typically, those costs are around about £30 per user per month. For an individual license, and as we've seen the proliferation of all these cloud-based apps alongside our own development, something like an Esri collector app, where a couple of years ago didn't have much functionality, now it is excellent compared to its predecessor, which was ArcPad. It's still got a way to go, but it performs very adequately as a cloud-based app for mobile GIS data capture. Another similar app is Fulcrum, albeit Fulcrum to a large extent doesn't have the GIS capability of Esri Collector. It works very well as a point-based feature capture or feature inspection application. So we're seeing a lot of our customers and certainly new customers wanting to link a piece of hardware to something like Fulcrum in the field. But where we see our own Geography M application sitting somewhere in between an enterprise level application such as Esri Collector and some of the cloud-based apps that are available, where we've closely tracked a lot of the field mapping requirements for those people who've maybe used Digiterra in the past, and alongside that we've made sure that we have all the links to external sensors such as GNSS capability. So just a couple of slides now on accuracy itself. So if you're wanting to improve the positional capability, the positional accuracy of features that you're capturing, whether they're point, line or area features, you really need to find what is the best type of external receiver to use. And one of the questions that a lot of people, we ask a lot of people is, well, what accuracy do you really need? And the reason that I enhance the word really is a lot of people think that they can achieve really high levels of accuracy at an increasingly low cost. But actually, for most mapping applications, a relative accuracy to the map is what's most important. So as long as you're achieving the accuracy of the map itself, so you're plotting the feature in the right place on the ground, then that's probably the accuracy you need. And nowadays, with the proliferation of external GPS receivers, does higher accuracy mean higher cost? And that's generally, reflective of the budget that you've got. But hopefully this next slide does explain it a little better. So what you can see here in the illustration is maybe somebody trying to map the location of a tree, and then the concentric circles that will actually slight ellipses around that position indicate the level of accuracy that you can achieve in the real world. So if you were down and if you have a survey grade receiver and you wanted to plot the position of that tree to within 10 centimeters, that is going to dictate the cost of that that external capability. Then as we move out the sort of the circles themselves, you'll see that typically a sub-meter receiver, a mapping grade receiver giving you accuracy of 60 centimeters would still plot the position of that tree roughly where it is, and actually that is what we class as map accuracy. So somewhere in between 1 meter and 10 centimeters is roughly where we would expect a sub-meter receiver to plot you in real time. But then as we move out again to the 1 meter space, that's starting to give some anomaly in the placement of that feature. So if you had a fence alongside, or you were working in somebody's back garden or near to a boundary, if you're plotting something only to 1 meter accuracy, you might then find it would plot you sort of the other side of the fence or in the wrong surface type, so it would be in the footpath as opposed to in the verge. And this is where anomalies start to occur. And so when we talk about mapping grade capability, we're usually recommending something which is at least sub-meter. And as you go into the sort of 3 to 5 meter category, this is where existing smartphones and tablets are limited in terms of their capability. So those using tablets and smartphones in the field with an application, if they're wanting to improve feature location, need to consider an enhancement or an augmentation to that handheld device in order to ensure that you're plotting features in the right location or the right side of the boundary, or when you're plotting closely spaced features, that they are going to be separated accordingly. I've just been asked a question actually about EGNOS, so I do have a slide on that that I'm going to come on to shortly, so I will be answering that question within the next couple of slides. So you'll have heard me mention a term called GNSS, and most people are more familiar with the term GPS, but GNSS actually encompasses other satellite constellations that you have access to nowadays with technology. So GNSS stands for Global Navigation Satellite Systems, and the fully global constellations that exist within GNSS are GPS, which is the American-owned global positioning system, and GLONASS, which is the Russian Global Navigation Satellite System. And just as an example, so our Arrow series of GNSS receivers have full GNSS compatibility. And you'll also see in this next slide that there are other constellations of satellites being developed and deployed. So the Chinese are developing and deploying a system called Beidou, which is fully operational regionally and will also have worldwide coverage within 3 years or so. More interestingly to us, based in the UK, is Galileo, which has seemingly been in development for a long time now, certainly in the last 10 years. But now we're reaching the point where, through ramped up European funding through the EU and the European Space Agency, we do have test signals available today, with a commitment to having a full service available as early as next year, 2018. And there seems to be an increase in activity, possibly partly due to Brexit, but certainly we will start to be able to take advantage of the availability of Galileo very soon. I mean, you'll find again with a lot of the receivers that are now on the market, certainly with the receivers that we recommend in all our solutions, they will increasingly have capability and capacity to receive satellite positional signals from Galileo very soon. So SPass, which in Europe actually is EGNOS. SPass stands for Satellite-Based Augmentation Systems. These are free geostationary correction services that are provided worldwide and enable accuracy down to sub-meter depending on the type of equipment that we're using. So the EGNOS service, which we have visibility of in Europe, stands for European Geostationary Navigation Overlay System, is a band of 3 satellites which augment and provide a free-to-air correction to any available receiver. Now, one of the limitations of SPass, even though it's free, is that you do need a direct line of sight to the satellite itself in orbit in order to receive a correction service. But this very often just means that you are rotating or orientating yourself to the direction of line of sight of the satellite itself. And just to give you an overview of the SPass coverage worldwide, you'll see in the center of that map, the EGNOS service actually gives a full Western European coverage and actually touches parts of North Africa now. But there are other SPass constellations around the world. So if you're having to travel overseas, you'll see both those areas which are compatible with SPass, such as North America, India, and Japan, and parts of China now with the GNSS system. But as you move into more equatorial and southern hemisphere regions, you don't have coverage with SPass. So if you travel into these regions, you need to look at some other source of correction to give you at least sub-meter accuracy. And this is where other types of real-time correction sources are available. So you'll see what I call network VRS, which is based on in the UK an internet-enabled correction service, which is operated by Ordnance Survey in the UK. These things exist in various parts of the world, but they are subscription services. There are also some other types of satellite-based correction services available worldwide. And with the Arrow series of receivers, for instance, there's a global constellation of satellites which are called the Atlas service. And you can subscribe to these services to give you either 30 centimeter with H30 service or 10 centimeter coverage with the H10 service at a cost And these subscription services are much more flexible, so it's not an annual subscription that you have to sign up to. They can be as few as periodic as 1 month, so you can sign up for these services on a monthly basis. And as I mentioned with the Arrow services, you generally need an additional antenna, external antenna, in order to receive these corrections. But the Arrow series have the L-band capability to receive Atlas built in. So you don't need to purchase additional hardware with an Arrow receiver, but you will find that the subscription costs themselves are a lot more flexible than with the network VRS subscriptions. Just in answer to a quick question that was covered by the previous slide, is SPass coverage available for East Africa? In our experience, because of the position of the geostationary satellites, you will not get SPass coverage in East Africa. Certain parts of the tip of North Africa and into the Middle East, so Egypt, Morocco, Tunisia, you will be able to pick up SPass, but as you move further south, maybe into Nigeria, Kenya, Tanzania, Ethiopia, Sudan, you wouldn't really get a guaranteed SPass service. Hope that answers the question there. So we just wanted to touch on some examples of use cases where we found our recommendations have really provided a good return on investment. The first one is a more recent application where we were involved with a company in Ireland who undertake field ecology, and what they were needing to do was improve the accuracy of the data they were capturing in the field, but also have the ability to work with an existing solution, which in this case was Esri Collector. So what they wanted is to have a plug-and-play sub-meter capable GPS receiver that they could use on consumer-level devices. So it might be an iPhone or an iPad or an Android device. And the Arrow 100, which was the solution that we recommended and shown in the picture here, has a very simple Bluetooth connection and works nicely within Esri Collector. So you can connect the Bluetooth device to Esri Collector. You can wear the GPS receiver on a belt clip that's provided with it or in the backpack, and the antenna itself can either be worn in the backpack or in the supplied cap. So you get a good wearable Bluetooth-enabled sub-meter solution in the field at relatively low cost. And you're also able to capture within Esri Collector all those GNSS quality statements, such as the number of satellites and the estimated accuracy as attributes. So you've got some diagnostics and QA information which is being captured alongside. The other nice thing about Esri Collector is that you've got the ability to share data via a subscription to ArcGIS Online. So this customer actually found a very quick return on their investment because they were delivering the accuracy they needed into an enterprise level application. The second example really touches on one of our core market sectors, which is in arboriculture. And with this particular customer, they were really starting from a much a much lower requirement, where they actually needed to go out and capture something into a database that maybe had some existing attributes. So the database itself needed setting up alongside some form of GIS desktop tool, and then the requirement was to take the information out into the field and update the database both with coordinates and have the ability then to perform annual inspections for tree risk. This particular customer had about 1,700 trees as part of an arboretum, And through a consultancy with ourselves, what we actually recommended was a system which was based on the use of open source QGIS, with a database sitting behind it, and then a rugged handheld device for capturing and updating the database in the field. So the chosen solution was our GeoGraph-EM, and more recently including within the Spatial Hub. And I'll be given a quick demonstration of the capability of GeoM and Spatial Hub just a few slides away. But in this particular instance, the customer, within a very short space of time, had been able to go out and capture with a sub-meter capable receiver GNSS data for all 1,700 trees, and is now in a position where they've got a fully populated database that they can start to undertake inspections on. The next stage for them is actually to provide some form of public facing website that we're just in the process of specifying and developing for them. So anyone who visits the Arboretum will also be able to see and locate any specific tree and its details in real time. So it's a fully end-to-end solution that we've been able to develop for this customer, and actually with a public resource that will give them not only an archive, but something that people visiting the Arboretum will be able to use. So this was a real success story, certainly by leveraging open source GIS and without the need to pull in expert resources in order to develop the product. The third use case here was one of our enterprise level clients, Northumbrian Water, who actually brought us in, again, a very early stage of trying to determine what the business requirement was for mobile GIS. So Northumbrian Water have a fully fledged existing enterprise GIS system, but still we're finding that they had a mix of end user requirements and end user use of mobile GIS. So what they wanted to do was try and find a quick and easy way of deploying a sort of multiple different task-based applications in mobile GIS in the field. So, excuse me. Just take on some water. We looked at some of the legacy applications that existed within Northumbrian Water, and partly because of their potential move to an Esri application, also started to look at using Esri Collector for a number of different task-based applications, but also a number of different accuracy requirements. So they had a lot of people who maybe only needed mapping grade accuracy in the field, or the ability to record features to within a decent degree of accuracy, but also then within this specific application, which was capturing wastewater or sewer surveys, they needed to ensure that the data was captured both in 2D, X and Y, but also in 3D with very accurate elevations. So what we recommended to Northumbrian Water was a range of GNSS receivers which covered all accuracy requirements. And because the Arrow series GNSS receivers are external, plug and play, they were able to share this, or are able to share this as a resource around the business. So what they were able to demonstrate, both as a business case exercise, but also into lots of different application areas, was that by using something like Esri Collector, you would be very quick to deploy both existing network information, mapping data, and some easy to use data capture applications in the field, and be able to share that information back within the enterprise without the need for lots of different back office integration. And what they found on the back of deploying something like Esri Collector with the Arrow series is that they're getting people coming to the GIS team with new applications almost on a weekly basis, which is great news for the enterprise because it's widening adoption of GIS in a mobile sense. but it's also encouraging people to move away from siloed data and legacy applications into something which is much easier to manage across the enterprise. So again, just a quick look at our own application. So what we've, as MGIS, looked to develop, certainly over the last couple of years, is an approach which gives people the ability to use different components, either to plug into an existing simple workflow that they've got, or to look at using different components to build an end-to-end application based on our knowledge and experience within the industry. So within our geography spatial hub, there are 5 different components which comprise mobile, database, reporting, web, and analytics. And as an end user, you can subscribe to or use any or all of these components as part of a solution. And traditionally, we've worked within the mobile and reporting space, but with the development of other spatial components, we've now got web analytics and database connectivity, both through open source solutions and also our own developed plugins for those open source solutions. So I'll just touch on that. So within the Geography M field application interface, you've got the ability to run this on a Windows or an Android device. So it might be a smartphone or a tablet or an existing piece of hardware that you're still using, which might run Windows Mobile. And then within the application, you've got the ability to serve master map data or any level of Ordnance Survey data, either live in the field or in a disconnected way, being able to take just that portion of data that you might want to work on at any moment in time. So we've both, with GOM, got a connected and disconnected capability where we're hosting data for you. You're hosting data that you might want to serve to your field operators, or be able to pull down the data you need for that daily task and take that out into the field. And alongside that, then, a form-based approach to data capture. So it might be something like a BS5837 workflow or template that you sit on the device or synchronize the device, and it's just menu-driven data capture. So from very simple startup, you open the app, you can plot your location within the map interface, and then that automatically brings up the form for you to capture all the other information, including photos and laser measurements. For instance, if you wanted to record the position or offset, the height of a tree, you can record that directly into the form and onto the map in real time. Other types of sensors, such as the spike, can plug and play into the GOM application, and this allows you to not only capture the position of a feature remote or which is not accessible, but you can also then take measurements within the image because you've got a laser offset and the capability to draw dimensions on the picture itself. That can be stored away, linked to the form, and then shared back, synchronized or downloaded back to the office when you get away from site. So again, there's both a disconnected and connected approach, but we're integrating other types of sensors into the application all the time. Within the spatial environment itself, this is controlled by an authenticated login, which allows you to see your data that you've captured. It allows you to report on that data. It allows you to see all the linked images. So there's a lot of functionality being built into this based on user requirement, which allows people to do things like view data, style data, filter data by attribute. You're able to print out reports or export into a number of different formats, from CSV to shapefile to KML, but again, focusing on simplicity of use. So this is really a web-based application that allows people to do lots of commonly used GIS tasks without having to pay for enterprise level applications. But we can also then develop this as a complete bespoke solution for customers at the same time. And in a follow-up webinar, we will be doing a full live demonstration of both GOM and the Spatial Hub. This is just really an introduction to the capability, either to those who are looking to migrate from an existing application like Digiterra, who are maybe looking for something other than an Esri environment, or maybe looking for some advice as to which components will best serve their needs. And alongside a lot of the software and GIS capability, one of the things that we're very conscious of is people's need to capture other types of sensor-based information. So within the application, we've got links to laser rangefinders, but also buried cable locators, DSLR cameras, and increasingly people are looking to use a tablet-based application not only to capture positional data, but also to use it for capturing ground control for drone use. So we're seeing a lot of people using a single hardware platform for capturing drone-based data, but also then using the same tablet environment with a GPS sensor to capture ground-based control points, and that's enabling them to have very accurate fixed orthomosaic data in the field. That might be something that you would want to discuss with MGIS, either provision as a software tool or as a service which we can provide in the field. So just as a quick comparison of equipment purchase to rental options, very often people's software requirements are fixed and ongoing. So you might have an existing CAD or GIS system that you need to use for analysis, reporting, and for database capability. And these types of application are generally purchased as an annual supported cost within the business. But alongside that, you might only have a periodic or seasonal need for GNSS, either to improve the quality of project-based data that you're capturing in the field, or as a shared resource around the business. So as opposed to buying up front a fully integrated GNSS-enabled system, why not look at rental options that we provide, which will give you, anything from sub-meter map-based accuracy down to sub 10 centimeter or survey grade accuracy in the field on as frequent as a weekly basis. So we have both the hardware rental options available with a minimum of a week, but we also then alongside that have software rental options. So if you need additional capability which your current software application doesn't have available, and something which is out the box serving a specific accuracy requirement, then we can obviously then offer you that on a weekly rental basis, which when compared to purchase costs, so if you're looking at something like a sub-meter GNSS receiver, the costs of which are roughly £2,000, down to a survey grade receiver system, which you're then needing to look at a cost of around about £7,000. Your rental costs at a sub-meter level are from £150 a week to an RTK or sub 10 centimeter system, which roughly speaking would cost you around about £300 per week. But for those short-term projects, the rental option might be a much more cost-effective. And alongside that, we can also provide via these flexible correction service subscriptions, correction services, either in those areas that don't give you free-to-air corrections such as SPass, or for those applications that need a higher level of accuracy, correction services which will cost you roughly £50 to £100 per month depending on the accuracy requirement. So really what we're trying to promote here is, for those people looking at the sort of the seasonal activity which tends to ramp up in the spring, flexible options for project-based work as opposed to a full-scale investment And it's just something that we keep getting asked for. So we're looking to roll out a fleet of hire equipment across the 2017 spring period. So again, any feedback and information you require, please feel free to reach out and contact us. And that's just really a quick run through of what we see as the most commonly asked questions to us as a business, most commonly asked questions from clients, but also then trying to answer those questions and provide solutions to people on a seasonal basis. You can see here, our web address, our sales and information contact addresses, and also our office address. We recently moved office to a much more suitable location in Liverpool. So that really covers what I wanted to run through today, but we have got some time left for questions. If people want to maybe use the chat box, we'll stay online for a short time. I know I answered a couple of questions during the presentation, so it may well be that you've either got questions that you want to ask now or want to ask via email. I did have one question which was asked, which really started us looking at the provision of rental equipment, which was availability. So what we tend to find is that people at the start of a project are looking to hire equipment for the start of the following week. So what we try to commit to is, if somebody has got a requirement at the start of a specific week or month for equipment, that we have around about 3 to 5 days notice. So we can supply equipment which is fully compatible with your application, or supplied with a software application itself, ready to go out the box within around a 3 to 5 day period. And the requirement from your end is to commit to a minimum period of 1 week's rent. So for instance, if you were hiring an Arrow 100 for a week, it would cost you £150 plus VAT, shipping cost, and then the RTK systems are available complete with software and hardware platform for £300 a week. So you'll find as a minimum cost £150 up to £300 a week, and then alongside that your requirement for additional subscription, and that roughly covers your complete cost on a weekly basis for rental equipment. I've also just been asked the question about the Spike laser range finder. So Spike is a product that I actually worked quite closely with during its development with Ike GPS, who manufactured the product. And Spike is a product, since its launch in late 2015, we've been working quite closely with in terms of its integration with our own platform in Geography M. The way Spike works is again via Bluetooth, but it allows you to capture a photo and then measurements within that photo itself. So in terms of its accuracy, you'll generally find it'll give you accuracy relative to the position that you're standing. So if you're working within a proximity of about 30 to 50 meters, then you'll be able to get a measurement accuracy of height and spread of the tree within a couple of decimeters, which is typically, again, giving people what they need, relatively speaking. If you wanted to improve on that accuracy, or you had an existing laser device, such as a True Pulse or a Laser Ace, we also have Bluetooth capability with those devices, so you can use existing laser devices with the GeoM platform in real time. We did, and we have got some videos available on our website which show Spike being used for capturing tree-based information. So we'll maybe send out those links alongside the links to this presentation itself, which will be available afterwards. Just one more question on the GOM field app itself. There are two options available for GOM, both as an upfront license cost and as a monthly subscription paid annually. So if you were looking to purchase a license of GOM, the license cost up front is £750, whereas the subscription cost paid annually is £49 a month. So it really depends on what you would prefer, an upfront license cost or a subscription cost. We also have a migration route for existing Digitera customers who are looking to move to GOM, where there's an upgrade route which rolls into your existing technical support contract, and we have actually sent out information to all Digitera customers about that migration route, which can actually fall in line with your renewal date for Digitera technical support. I think one other question which might be relevant is in looking at the relative advantages of Collector compared to maybe other applications in the field. And I did allude to the fact that Esri Collector has undergone a significant amount of development just recently, to the point where we're seeing a lot of our PAD customers, which is a legacy Esri field application, now moving across to Collector. But I guess it still does have some limitations. One of the things that certainly our customers benefit from greatly is the ability to work with vector data in the field and the ability to snap to vector data. Something like Esri Collector currently doesn't have snapping capability in the field. So it's those bits of functionality that we find people have a requirement for, and then need maybe a more functional type of mapping application in the field that would sort of drive us towards recommendation of something like GOM. There is a comparison table that we put together looking at the relative merits of GOM and Esri Collector. And what I can do is also publish that information and make that available, really to answer this question. So I'll make sure that the relevant people get access to that comparison table. And just one further question about subscription costs. You'll find with something like Esri Collector that the more users you have, the lower the subscription cost is. That absolutely is the case with something like GOM. So we have various thresholds available based on a volume requirement, but that tends to be on a request basis. So for instance, if you've got a requirement to shift a whole volume of users from one application to another, then that would be reflected in the subscription costs that you would pay. And as I say, happy to provide information on that on an individual basis if somebody's got a specific request or an existing volume of users that they're wanting to maybe look at from a budget point of view, switching them across. I hope that answers the question. So we're coming to the end now of our allotted time, and I really value the fact that you've stayed online with us for the full hour. I understand that there might be some follow-up. So any of the contact methods, any of the specific parts of the presentation that you maybe want to see on a one-to-one basis, more than happy to provide specific webinars for companies, or even as a one-to-one basis. So reach out with any specific workflow requirement you've got, and we can maybe provide more of a tailored application for you. Follow webinar next week is actually focusing on utility and infrastructure applications, and we will be doing a full live demo of GOM and the Spatial Hub application for our customers. So we'll be sending out details of that later this week, either on a one-to-one basis or via this webinar approach. So it'd be great to get your feedback, actually positive and negative, and how you found this, whether you would feel that using the webinar would be a good tool for providing these online educational courses or even training, or whether you might prefer something which is more tailored to your needs and office based. So please let us know. But all it remains for me to do is say thank you for your time today. I hope you found it of use. Please get in touch with any further questions you've got, and keep us posted, or we'll certainly keep you posted on any upcoming webinars and training that we're running through this facility. So thank you very much for your time, and hopefully we get to speak to you again soon. Bye for now.